Good morning, students. In continuation with my earlier lectures, today we'll continue with the further topics and in electrical installations, fundamentals of electrical engineering. I am Pankaj Kumar Gupta from ABS Engineering Service. Now, in my earlier lectures, I have delivered these following topics. That is the switch fuse unit, miniature circuit breaker, earth leakage circuit breaker, air blast circuit breaker, earthing, cable and wires. Today I will deliver the lecture 7 with regard to bus bar arrangement. Now first we should understand what we mean by bus bar. Now it is one of the vital elements in electrical power stations and substations. We'll always find there. Now bus bar is convenient means of connecting switches and other equipments into various arrangements. Busbar are used in substation is usually bare rectangular cross-section bars made up of aluminum. Most probably it is made up of aluminum metal. When a fault occurs in a bus bar, considerable damage and disruption of supply will occur, and the system stability will be seriously affected. Hence, proper protection of bus bar is needed. Now, the choice of any particular arrangement depends upon the system voltage, position of substation in the system, reliability of supply, and flexibility and cost. Now, bus bar, let me just remind you that bus bar is actually an aluminum, it's a rectangular, as we've seen in the third point, it's a rectangular cross-section bar. Now, in these bus bars, we can connect any electrical load, maybe motor, we can cable, depending upon the requirement. But under all circumstances, the voltage across each and every load which is being connected to that particular bus bar will remain same, will remain constant. If the bus bar is made to deliver 440 volts, any equipment which is being added to that bus bar will always have an input supply of 440 volts. That we will see later on in the arrangements. That we will see, and I'll explain. It's very, very vital because it's very convenient for us to even add up the electrical loads. Now, the first type of arrangement, that is called the single bus bar arrangement. Now here, if you look into the diagram, the blue line is the single line diagram because there's only one kind of bus bar in this system. Now if you see the two circuit breakers, which is in the yellow color here, it is in the yellow points, and these are the two generating stations, mean generators. They are connected to the circuit breaker and the isolators. Both are, we have discussed in the previous lectures. These are nothing but your circuit breakers. They may be an high voltage circuit breaker because here we are using generating station of 11,000 volts. Now this is connected, both the generators are connected to the bus bar. Now suppose I am generating 11,000 volts. So across this bus bar, at any point, the voltage will be 11,000. Now this is the incoming terminals. आपकी जो incoming supply है, these are the incoming bus cables. The outgoing are having also similar circuit but a different. Here also we have isolators and circuit breakers in all the three loads, outgoing feeders we can say, and they are all connected to the transformer. The transformer either steps up the voltage or steps down the voltage. Either the voltage will be step up or the voltage will be step down. Now it all depends upon the requirement. Normally these These lines are being used for transmission. So normally what we'll do is if we are generating 11,000 from the bus bar, there'll be also 11,000 available at the primary end of the transformer at these three ends. So transmission voltages are always higher than the generating stations. So maybe they may step up to 440 volt, maybe also 440 kV, 440 kV, maybe 135, maybe 110 kV. We are generating 11,000. Here we are transmitting the line from 6 maybe at 23 kV, 21 kV, 21,000 volts, or 110 kV, maybe 440. That all depends upon the requirement, system requirement. Here the bus bar is only single. That is why it is called single bar bus arrangement. Now this is the simplest arrangement consisting of a single set of bus bar for the full length of switchboard. Now this is a switchboard. I can connect any number of loads and to the set of generator, transformers and feeders. Now generator is the upper part. Transformers are these green coils which you are seeing, the 6 coils, and the outgoing feeders are connected to this bus bar. Now the main drawback of the system is that in case of fault, if any fault occurs on the bus bar, the whole system collapses. All the healthy feeders are disconnected. If there is any fault, if any fault occurs here and there, all the system will collapse. There will be no transmission of power from the generating end to the transmission end. It is employed for switchgears, small and medium size, and most probably from substation to DC station, small power stations. There also we are generating 11,000 volts to a DC station. They are used for small sizes, very small sizes, where the system is very small. So the important part is this blue line, which is nothing but the bus bar. At this bus bar, whatever is the generating voltage, maybe 440, maybe 400 volts, maybe 11,000, that voltages will be available at the bus bar throughout that bus bar. And from there we can connect any number of loads. Yeah, any outgoing feeders can be connected with the help of the required as per the requirement. Now the second is double bus bar arrangement. Here, instead of having one single bus bar arrangement, we have two double bus bar arrangements. So here incoming and outgoing are connected to main bar and the auxiliary bus bar. The loads are also divided accordingly because all loads in the circuit is connected in parallel. We can connect the load in parallel and create more loads at this feeder. So the feeders, here we are having 3 feeders, but each feeder is having 2 parallel paths. So whatever will be the generating voltage will be available at the main bar and auxiliary bus bar. Now this type of arrangement does not require any bus coupler. The bus coupler is basically a isolator between any two loads. I can create a bus coupler here also, here also. This type of arrangement can permit switchover from one bus to another bus without interruption. Because if any fault occurs on the main bar, we can use it the second bus for transmission of power. So what will happen? There will be no continuity of power flow from the generating side to the outgoing feeders. But here also a drawback. The cost and maintenance cost is very high. Now to maintain these two bus bar, it is very high. This is the main drawback of this double bus bar arrangement. It provides maximum flexibility and reliability that we have seen because see, here I've got two bus bars. There are two bus bars, main and auxiliary, and the two bus bars, the generating is also connected to both the bus bars. In case of fault in any one of the bus bar, either it be main bus bar or auxiliary bus bar, the power flow will still continue from the generator to the feeder by the second path. It provides maximum flexibility and reliability. In case of maintenance of a circuit breaker, it can be shifted to other circuit breaker. It's very convenient, very easy. It's very simple. If I require any maintenance, see with regard to outgoing feeders. Here I've got two circuit breakers. Now if this circuit breaker requires any maintenance, emergency, in case of emergency, then the total load of this feeder can be shifted to the other breakers. So it's a very convenient way of shifting load from one circuit breaker to the other. So there will be no discontinuity of the power being transmitted from being transferred from generator to the outgoing. Now the third is your ring bus bar arrangement. Here the ring bar it's a ring. There are two parallel lines, but it's forming a ring. So the three generators are connected to the bus, and here also we have the same functions. The functions are same, but here the arrangement is different. Here we have got a bus coupler to isolate the two buses in case of any fault. Generator will generate electricity and will transfer the power to the outgoing feeder. Here high reliability, less number of circuit breaker is required. That is very important. Difficulties in addition of any new circuit in the ring. This is very important because in case if you add any load, we will have to disconnect the bus bars. And for that there will be the power transfer will be less because we have to shift the power from one circuit breaker to the other feeder. There is a possibility that we will not be able to shift the power, due to which outgoing feeders may get overloaded. There is a possibility, there is a difficulty. This is a drawback with regard to ring bus bar arrangement. Now here necessity of supplying demand potential to relay separately each of the circuits. Now here if there is any demand, then there is a problem with regard to the bus coupler because the ring it's informed in the ring. The power, the voltage will be only around the ring through the bus couplers. But the main advantage is the flexibility and reliability. It's very convenient. It's not that difficult as compared to single bus. As compared to single. And the last arrangement is the mesh bus bar arrangement. Here, all the breakers are connected in mesh form. Mesh is nothing but a closed circuit path. This is also a mesh bus coupler. Economical use of circuit breaker in the substation. Circuit breakers are installed in the mesh formed by the buses. These are all buses. These black lines all are buses, but they are formed in the mesh. Yeah, you can see a loop. It provides security against bus bar faults, needs a smaller number of circuit breakers, and used in substations having large number of circuits. It is vividly used in the substations, but there they have got very large amount of power to be transmitted, and the load is also very large. Because suppose if you are considering a distribution substation of any part of the city, then the load is very large. So there they are using mesh bar arrangement. Circuit breakers are placed vital role. They make circuit on and off. So that is why for each and every bus bar arrangement, we have circuit breaker to be provided. Because in case of any fault, then there will be a damage. It can damage even the bus bar. That is a costly issue. If there is a fault in the bus bar and to remove that fault, we have to replace those bus bars, then the overall cost of the substation or this power system will increase tremendously. These are the 4 references which I've used for the diagrams, and I've used this textbook, Electrical Power Systems by Dr. S.L. Paul and Professor. This is only for teaching and education purposes. Thank you, students.